So hi everyone, welcome to BigDataChamps, and this is the first session of our Big Data series that we have started. So in this particular session, what we will be doing is I'll be giving you an introduction, overview to big data and the Hadoop and its core components basically. So let's start with big data. So if I ask you like what is big data, so how you will be defining it, how you will tell in the layman terms. uh, so the term itself referring to big, if you see like the size. So if the size of the data is huge, you would be saying like yeah, this is the big data. But the thing is, what is that benchmark? Is there any benchmark or a number? Like we will be saying like if 100 GB is big data or 1 TB is big data or 100 TB is big data. Is there any benchmark to to check if the data is big data or not? Or are there any other factor that will help us to uh, define if a particular data is big data or not? So are there any other factor than uh, size also? So let's see. So I'll give you an three ways definition here. So yes, there are other factors that will help us to define if a particular data is big data or not. So we will be looking at that. So we have this three ways definition. Basically the three factors I would say that will help us to define if a data is big data or not. The first is the volume, size, that is nothing but the size of the data. Second is the velocity, that is nothing but the speed at which the data is coming from the source. And the fourth is the volume. Okay. Oh, sorry. It's a variety. It's a variety. So the first thing is volume, size. Size is nothing but if your system, your traditional system, your laptop, your desktop is not able to process the amount of data that if I give you, so I would say like that is the big data. Suppose if your system has, let's say, 8 GB RAM and let's suppose 1 TB hard disk or 8 CPU cores, then if I give you, let's say, 1 GB data, your system would be able to process it because it can 1 GB data can easily fit in your RAM, 8 GB RAM, and it can process it. But if I start like if I give you let's say 100 GB data, then it won't be able to process that 100 GB data because you just have 8 GB RAM. And in order to process the 100 GB data, that particular 100 GB data should fit in your 8 GB RAM. Okay, and that is not possible. So we will say like this is the big data for your system. Okay, then we have the velocity. So velocity is nothing but the speed at which the data is coming from some sources. For example, we have some sensors or a social media website that are generating the data every second. Okay, so suppose instead of giving you 100 GB file, what I'll give you is, let's say, 10 MB file, and I'll give you a 10 MB file every 5 seconds. So your task is to your system you have and the installed tool on that system, like you have to process that 10 MB data every 5 seconds, and on every 6 seconds you will get another 10 MB data. So if your system is not able to process the data at a speed at which it is coming from the source, so we will say yeah, again it is a big data. So this is the velocity or the speed of the another. And the third factor is the variety. Variety refers to the basically the different data types. What are the data types we have? We have the structured, we have semi structured, and we have unstructured data. So structured data is nothing but the data that is coming from the RDBMS data system, like the MySQL, Postgres, Oracle DB. So those are the like structured data that is in the form of the row, and that is in the form of the table. Semi-structured data is let's say are nothing but like CSV files, text-based format, I would say, the JSON file, XML files. And Excel data is like PDF, images, videos. So instead of giving you a single file, I'll give you multiple files of different data types. And if your system and the available tools on that system are not able to process this diverse uh, data type, uh, data with a diverse data type, then again I will say that is again a big data. Okay, so your traditional system, that your normal system you have, if that is not able to process the data considering these three factors, then we will be saying okay, this is the big data for your system. So we understood, okay, these are the three factors that define the big data, and your traditional system is not able to process it. Then okay, we will need some different system that will be able to process our data. So let's say types of systems we have. So we have, let's say we have two type of systems. First is a traditional system, that is nothing but a monolithic system. Another one is a distributed system. The traditional system is like a single system, uh, a single system where you have to perform all of your work or process all of your data, like your desktop, your laptop, computer, whatever you say. So that is a single system, that is a monolithic system, and that has to process all the tasks. And if it is not able to do, then you know uh, we we have defined the data as a big data. So okay, so let's see what are some properties or uh, of traditional system, I would say. So in traditional system, what we are doing, basically uh, we have to perform all the work on the single system only. So we have to perform all the task or the data that we have to process, we have to do that on the single system only. And it it can be scaled vertically. It can be scaled vertically only. What does it mean? Vertically mean, like in the single system only you will be increasing the resources. For example, you have, let's say, 8 GB RAM, and let's say 1 TB hard disk or 8 CPU core, processor. Then then we can add more number of RAM, like portable, into that system. We can add to a certain point only, but that is the thing, because you do not have 1000 GB RAM available, or so there is some hardware limitation that is there in the monolithic system. And because of that, after a certain point we hit a limit and we won't be able to scale it further. And vertical means, scaling vertical means we are adding adding uh, resource. What do my resource is? RAM and compute to, or I would say with within a single system only, and it is not highly scalable, because after a certain point there will be some hardware limitations. We do not have 1000 GB RAM available. Okay. Thousand, like a chip of 1000 GB RAM, that is not there, and it might not support if even if someone develop it. Okay, so uh, the third or the last one, I would say, so to a certain point you will be able to increase your RAM, as we have mentioned, like you, if you have 4 GB, you make it 8 GB, then 12 GB, 36, whatever. So after a certain point, you will hit a limit. So initially, if you are increasing your RAM or resources, I would say, your performance will also increase. But the as that hardware limitation hit, your performance also stop increasing there. So after a certain point performance of the system will not increase, as it will hit it, as it will not be scalable, as it will not be scalable. Okay, as it will not be scalable. Okay. So this is something the traditional system is. Then we have a distributed system. What a distributed system mean? Distributed system simply mean we have a group of machines, or you can say nodes, uh, combined as a single system, and the work will be divided across all the machines. So instead of having just a single system, we will have multiple systems, and across those multiple machines, we will distribute our data. And on those machines only, that those smaller chunks of data will be processed, and it can be and it and then we can say it can be horizontal. It can be scaled horizontally, and it is highly scalable. What do I mean by highly scalable is, or like horizontal scaling means, in the monolithic system, we were adding the resources to the same system only. But in when we say it is horizontally scalable, it means we have a group of machines. So we will be adding more machines instead of instead of increasing the resources as like in a single machine, we will increase the number of machines itself. So then, so in that case, it is, we can say, we are scaling is it we are scaling that system horizontally. And it is also, we also call it scaling out horizontally, scaling out horizontally, or in this case, we say it is also known as scaling up vertically. Okay. So here we are scaling horizontally means we are adding more number of resources, and there is no limitation in on adding number of resources, because you can buy any number of machines and you can add that in your system. But there is a limitation on hardware in the monolithic, that we, after a certain point, we do not have available like RAM of 1000 GB RAM. We are not don't have that, but we have number of machines. We can add, let's say, 8 GB RAM, and 8 CPU core machine, like multiple machines to our system, and we can make it highly scalable. And the last is, the performance will increase in the same proportion, and it will not hit any limit. The performance of the system will increase in the same proportion of resource increase, in the same proportion of resource. What I mean, as you increase the number of machines, as you keep adding number of machines, your performance of the system will be increasing in the same proportions. Machine. Okay. So this is the distributed system. Let me show you a diagram. So I have a diagram. So this is your you know monolithic, or I would say the traditional system. So you just have a single system, and you have just 8 GB RAM, some CPU cores, and some hard disk available, and you will be doing everything on the single system only. But in case of distributed system, In case of distributed system, if you see, you will be having some master node and the worker nodes. So master node is basically where you will be submitting your main code, whatever you have written, your main logic, and that logic or the code will be distributed to these workers nodes. And here, so what you will be doing, you have some, let's say, one big file you have divided in that four part, and you have stored those four part in these four machines, and you have then write some logic to process that data. Then you submitted that logic to this master node. So this master node will send that logic to all these worker nodes, and those small part of your data, or like the small chunks of your data will be processed individually, like and that too parallelly on these four machines. So now in this case, your data will be processed very efficiently, and that too very less time, using the distributed system. So this is just a very high level overview that I'm trying to give you, because like in the upcoming sessions, I will be covering everything in very depth. I will be covering like Hadoop, and like the main core components of that in very detail. But in this session, I'll just trying to give you an high level overview and trying to set up your fundamentals and the base, so that when we will be learning like advanced concept and in depth, you will not face any issue. So we should have our base strong. So we have understood, okay, this is like distributed system. So what we understood, okay, with the help of traditional system, we won't be able to do our or build our big data application. But distributed system is something that can help us, and that will help us basically to build a, a big data application, because it is distributing our work or processing across the systems and across the machine, and it is very efficient for data engineering load, or I would say workload. Now we are clear on part, like we need the distributed system, that we have understood. Okay, so since like if we choose like the distributed system, if you see, so you have your storage distributed across these multiple machines, and these multiple machines have their separate compute, or separate processor, separate RAM. Okay, so these storage and the compute part is already distributed across these, they have, these worker machines have their separate storage, separate computation. Okay, so if I say in the like layman term, to build a scalable big data application, let me increase the font size. To build a scalable big data application, we will basically we need two things. What are the two things? First is the distributed storage. The second thing is distributed compute. We need distributed storage, we need distributed compute. So, and once we have these two things, then only we will be able to build a scalable big data application. Okay, so we need these two things, and how we will get these two things is on distributed system, because distributed system provide us these two things, distributed storage and distributed compute, that we have understood. Okay, so the storage and this distributed compute is nothing but a physical entity. Storage, if I am saying storage, it is nothing but a hard disk, a chip that is there. And if I am talking about the compute, it is nothing but the processor chip or the RAM, that is also a chip. It's like a physical entity is there. These things will basically process our data, but we will need some framework or tool that we will be installing on these in this system, like and with the help of those framework, we will be writing some logic, we will writing our like transformation or validation or code, and those logic will be processed or executed on these machines. So we need some kind of tool or framework using which we will be writing our code. And basically those tool or framework will be helping us to do this processing on the distributed system. And we will also need some file system, some distributed file system that will help us to store the data on this distributed machine, or manage the data on this distributed machines. So we need so still now we have understood the physical part, like physical entities. These are the physical, like storage and the RAM. These are the physical part of the system. But we need some framework, that is a software part, the program. So we need framework and tools using which we will be writing the logic or the code which will further you know pro processed multiple machines on uh, distributed system. And what are those framework and tools we have? So we have Hadoop. Hadoop is the first ever you know framework developed to build big data applications. Okay. So Hadoop has three core components. It has Hadoop has three core components. What are the three core components? So let me show you. Uh, First is the HDFS. Second is MapReduce. Third is Yarn. So here we were discussing, okay, we have the distributed storage and compute, but we need some framework and some tool to basically help us to manage the data and to process the data that is present of multiple machines. Because what is happening in the traditional, if you see, suppose you were using, let's say, the pandas. In the traditional system, you were using pandas to process the data, or do some validation on top of the data. So pandas is a framework or a library that help us to process the data that is present on that machine itself, on the machine that on which the pandas is installed. So it cannot process the data that is available on some other machine. uh, but we need, in the distributed system, we need something else, we that something that can process the data that is present of multiple machines. Because if you see, like, I am just giving you example of pandas, because pandas was able to process the data that is present on that single machine only in the traditional system. But here we need some other framework that will help us to process the data that is present not on the single machine but on the multiple machines. So HDFS is a distributed file system that will help us to store and manage the data on distributed system. Okay, this is the part. This is the component. HDFS is the component that will be helping us to process the to store and manage the data. And MapReduce is a processing engine. It is processing engine. It is that framework that will be helping us to process the data that is present on these machines, multiple machines. We will be writing some MapReduce code, and we will submit that MapReduce code to this master node, and this master node will further send the data, send that particular MapReduce code to these machines. And that MapReduce code will be executed parallelly on these worker nodes, and our data will be will get processed parallelly on these worker machines. So it will be very efficient when it compared to the doing the computation or the processing on the single system, because in the in the distributed, our data will be processed, data will be data will be processed parallelly on the multiple machines. So it is a distributed processing engine, and you know it will be helping us to you know to process the big data present on data present across multiple machines. So okay, we understood this. But what is yarn then? Yarn is nothing but a yet another resource negotiator. It is a resource manager. So what is the work of resource manager? Okay, let's suppose you have, let's say, 100 GB file, and another file is 200 GB file. Those are some, like, this is, let's say, customers data, and this is, let's say, employees data, and you want to process these file like individually, like separately. So what you will do, you will write a MapReduce, you know MapReduce job 1 for this file, and you will write some MapReduce job for this file. Okay, so you will just for now, just try to understand it, like I don't think about like what will be the MapReduce or what will be the code. I'll explain everything, but just for you know high level, at the high level, just try to understand this. So suppose you have written job 1 for the 100 GB file, and job 2 for the 200 GB file. So you have submitted your 100 GB job 1 and job 2 here. Okay. So there has to be, there we will need some framework, the third framework, so that will be helping us to analyze the number of machines that will be required for job 1 and that will be required for job 2. Because let's suppose job 1, if job 1 need, let's say, 10 machines, then job, just for example, job 2 might need 20 machines. So who will be doing this calculation, like the number of machine, what are the number of machine that we will need? So resource manager is something that will be allocate calculating the number of resources, or it will help us to manage the number of these machines, or allocate the number of machines. Because if you have like 10 machines in your system, so there has to be some framework that will basically command those machines, uh, like please execute this job 1 on these machines, on these 10 machines, or execute this job 2 on these different 20 machines. So this framework will help us there to basically allocate or allocate locate and manage the resources at high level. Just try to understand this. I will explain this in detail in the upcoming lecture. So these are the core components basically, and using which we basically developing our big data application. So these are the core components. Okay, so now if I give you an example, just again a very high level example, how you will be building a big data application. So suppose you have the data sources, you have some data sources, you need your and let's suppose you want your data to be in HDFS. Then only, because you will be able to process it, you need the data in your data has to be present in HDFS, then only it will be processed by your MapReduce. So once you have the data in HDFS, what you will be doing, you will be doing processing. I will be doing processing using MapReduce, and then you will be doing some again you will be putting the data. You suppose you have processed some data, and you have did some transformation, so transform data will be stored again somewhere. So for example, for now, let's suppose I again stored it in HDFS, and now you want to do some analysis uh, on top of this data. So for analysis, you will need again some tool, and yeah, the data that is present in the data source, that has to be moved the data has to be moved to the HDFS. Again, you need some tool. You need some tool here. Again, you need some tool here as well to do some analysis, to write some query, and that will be, for the analysis purpose. So where is this tool? What are these tools? So in the Hadoop, as I mentioned, it is not a single tool. It is a Hadoop is basically a ecosystem of tools. Hadoop is an ecosystem of tools. Okay, and these three things are the core components, because like can say the founder of Hadoop has developed these three main core components of Hadoop. So what people later realize is like, okay, we also need some tools for different use cases, because our data is present on the data source, but we need the data in the HDFS. So we will build some tool, and this tool you can say a ingestion tool. And these tools are and here we basically uh, we have the warehouse data warehousing tool. So using this data warehousing tool, you will be doing some analysis. Using ingestion tool, you will be basically moving the data from source to your HDFS. So these are the tools that are again developed under the Hadoop ecosystem, because these tools are under the hood under the hood running the MapReduce job only. So what are the tools? So I'll list some like main tools. We have Scoop, we have Hive, we have HBase, we have let's say Pig, we have Uzi, we have Uzi. So Scoop is that ingestion tool that will be helping us to basically transfer or move the data from data sources to HDFS. Hive is basically a data warehousing tool. So using Hive, so we'll be using the Hive, and we will be writing some queries in Hive, and on top of the data that we have processed, and we will be doing some analysis on top of that. Okay, and we will be like writing some queries to calculate the KPIs. Okay, like the number of order placed the in a particular month, the number of order, the amount of amount spent by a particular customer in a particular month or a particular year. These are some analysis. For those analysis, we will be writing some queries in the data warehousing, using the data warehousing tool, which is nothing but the Hive. Okay, so that's why these tools have been developed to for these different use cases. Okay, and under the hood, these tools are running MapReduce jobs only. Under the hood, they are utilizing the core component only of the Hadoop, because these tools are developed for the to basically support the Hadoop ecosystem, to basically support the Hadoop, so that we can develop the big data application using Hadoop. So HBase is a NoSQL database. Pig is scripting language to clean the data. Then we have Uzi to basically define and orchestrate the workflow of MapReduce jobs. So these are some like tools. There are multiple like other tools also. I just gave you an overview of the tool and how these are developed and what are the use cases and why these tools are developed, and under the hood what these tools are doing. They are running the MapReduce job only. So this is what it is. I have explained. Okay, so we have understood also the like software part. We earlier in the we understood the physical part, like we needed distributed system. Then we understood, okay, we also need some framework that has to be installed on this the physical system, like distributed machines. And these I've covered. We have Hadoop and the core components. These are the components that will be installed on these machines, and we will be using these tools for the different use cases. Like for ingestion, we will be using this. For data warehousing, we will be using this. So that is a different thing. So as so far, like HDFS, everyone should be using HDFS if it is like such a good distributing engine. So why there is a like noise about Spark, and why the companies are requiring engineers that know Spark? So there might be some challenges that viewer companies are facing in MapReduce. So there are some challenges actually. Challenges with MapReduce. So there are some challenges that the companies are facing, or I would say we are facing with MapReduce. So what are the challenges? Let's see. So the first challenge I would say it is the learning curve is high. And what do you mean by that? That you need to learn multiple tools. You need to learn multiple tools. Like you need to learn scope for different use case, high for different use case, Uzi for different use case. So the learning curve is very high. And the another thing is you need to write a lot of code, and that too in you know Java, to implement even a small logic. You have to write a lot of code, and that I'll be showing you in the next lecture or next session. Like just to count the number of words in the text file, there has to be, we have to write a lot of code, and that too in Java. And the another thing is it only support batch processing. What do you mean by batch processing? Is like we will be processing a huge amount of data at a fixed interval, like say like every 12 hour, every 24 hour, we will be having some data that has came from the source, and we have to process that data uh, after a a fixed schedule interval. So that is a batch processing. So just uh, it doesn't support the streaming processing. Like it cannot process the data in the real time for that is coming from the source. Let's suppose like you have some sensors or the social media apps that is generating data every second, so that cannot be processed using the MapReduce. Okay, for that we have different frameworks that will be discussed for sure. And the another thing is it is a disk based processing engine. I'll explain what the disk based and the memory based processing mean in the new session, in the upcoming session. Because if I now explain it, it will like again take another 10-20 minutes. So just for now, it you can assume it reading the data from the disk, and again writing the par- partially processed data into the disk. Okay, so it will be reading the data from the disk, then writing to the disk again and again until it will completely process the data. So just it is just a high level overview. I'll explain that in depth. Okay, so these are some challenges that basically you are facing. And the another thing when I can write is it is slow slow processing. It provides slow processing when it compared to the other framework that we will be discussing, like Spark. It is almost, let's say, Spark is almost 10 to 100x faster than MapReduce. So these are the challenges that we were facing with the MapReduce. And to so then only like then Spark came into the picture, and it solved all of these challenges, and solved all these challenges. So for this session, we have covered a lot, and I'll be uploading these notes. Okay, and I'll provide the link in the description. You can take the notes from there. So yeah, that's it for this session. We will meet in the next session.